this lecture. As you know, the building block of every major compartment of our body, including protein, the building block is amino acid. Carbohydrate, the building block is monosaccharide, glucose. And here in this subject, I'm going to talk about the lipid metabolism. The building block of the lipid of fat in our body is fatty acid. In basic term, the definition of fatty acid defined as a carboxylic acid with the hydrocarbon chains ranging from 4 to 36 carbon. Of course, in some fatty acid, this chain might be unbranched and fully saturated. That means there is no double bond. This is called saturated. When there is one or more double bond, this called unsaturated fatty acid. As easy as that. Fatty acid fill two major roles in our body. The first important one act as a component of more complex, as we said in the last lecture, is a building block of a bilayer cell membrane of our body in form of phospholipid or cholesterol ester, both of them associated with fatty acid. And the second most important role or function of fatty acid act as a major component of stored fat in form of triacyl glycerol, which is neutral fat, which is called triglycerides, which is the second most important source of energy in our body next to the carbohydrate in form of glucose. Regarding the classification of fatty acid, this classification is so simple. The classification of fatty acid either depending on the total number of the carbon atoms, whether odd or even. So if the fatty acid contain even number called even chain fatty acid, that's mean have carbon atoms 2, 4, 8, 12, 16, 20, etc. and similar series. And most of, please focus with me, most of naturally occurring lipids contain even chain fatty acid, not odd chain. The other type, which is the odd chain fatty acid, that's mean having carbon atoms 3, 5, 7, 9, 11, 13, etc. And odd number fatty acid are seen in microbial cell wall and may present in the milk. The second type or second classification is depend on the length of the hydrocarbon chain. As you see here, we can divide the fatty acid into three types: short chain fatty acid, medium chain fatty acid, long chain fatty acid, depending on the number of the carbon atoms it contains. The short chain contain 2 to 6, the medium chain contain 8 to 14 atoms, carbon atoms, and the long chains and very long chain fatty acid with 16 and above. And the last classification, this depending on the nature of the hydrocarbon chain of the fatty acid. As we said in the starting of this lecture, the saturated fatty acid is closely packed carbons، يعني كربون atoms متراصة واحدة بعد الأخرى بشكل مضغوط، لذلك called saturated fatty acid, and there is no double bond and less branches if we make a comparison between the saturated and unsaturated fatty acid. إن شاء الله واضح كلامي. The second type of unsaturated fatty acid, from its name, unsaturated غير مشبع, which may be classified into monounsaturated, which contains single double bond, or polyunsaturated fatty acid, which contain two or more double bonds. And this is loosely, not closely, loosely packed because of the presence of the double bond. This may kinking in the fatty acid chains. For that reasons, the oil lipid mainly made from mono and polyunsaturated fatty acid, while lipid in fat solid form mainly made from the saturated fatty acid. And the last one is branch chain fatty acid, like phytinic acid that present in tea بالشاي. أوراق الشاي بها نوع من أنواع الفاتي acid called branch fatty acid اللي هو phytinic acid. Now we're talking about a short note about each type. Regarding the saturated fatty acid, they have the general structural formula. This formula is required from you. If I write this formula with a different number, as you see here, the general structural formula CH3 methyl group CH2 in a bracket between قوسين N. here أنا أغير لك وين بالN إذا قلت لك الN 12 the last one ده الكربوكسيل جروب COH أنت تعرف لي تحسب لي CH3 هي 1 CH2 مرفوعة علما للN for example 12 والCOO3 الكربوكسيل يعني كم كربون اتمز يصير هذا الفاتي اسيد اذا اعطيتك 12 يعني يصير كربوكسيل هاي واحد 12 ايش قاعد يصير 13 والمثل 14 شو اسمه هذا الفاتي اسيد this is requested from you هاي مطلوب منك يا طلاب يعني انا اجيب لك تقول لي مثلا اقول لك the stearic acid is contain 16 carbon atom 18 carbon atom 14 carbon atoms and etc. You have to know this, please. This is easy. They are named. This is for clarification, for observation. The speaking next to this. They are named by adding the suffix anoic. This is for you. After the hydrocarbon with the same number of the carbon atom. Of course, each animal species, including human being, have a characteristic pattern of fatty acid composition. Here, I just mentioned the composition of our body, in human body. The fat contains 50% oleic acid, 25% palmitic acid, 16 carbon atom, and 10% linoleic acid, 18 carbon atoms, and 5% stearic acid, 14 carbon atoms. The carbon atoms of fatty acid are numbered in two ways, either starting from the carboxyl group, the COOH, or starting from the methyl group, CH3, from the left hand. If we starting from the carboxyl group, so the first carbon atom called carbon 1, alpha, carbon 2, beta. If we started from the methyl group, this the first methyl group called omega 1 and the second one omega 2 and etc. As easy as that. Regarding the unsaturated fatty acid, they are otherwise named by adding the suffix enoic. There, enoic, here, enoic after the systematic name. They are similar to saturated fatty acid in the reaction of the carboxyl group. The reaction is the same, but have an additional properties due to the presence of the double bond. لها خصائص إضافية بسبب وجود الآصرة المزدوجة. Nearly all natural occurring. Here, this is the important. ممكن يجيكم MCQ. Nearly all the naturally occurring unsaturated fatty acid, the double bond are in cis configuration. What I mean by cis configuration? I mean the group around the double bond lie on the same side, while trans configuration mean the groups around the double bond are on the opposite side. And I give you an example here. For example, 18 carbon atom fatty acid with one double bond between carbon 9 and 10 in cis configuration form called oleic acid, while in trans configuration form called iliadic acid. This is for observation only. But I want you to know the cis configuration is the naturally occurring one, the most common type of occurrence of unsaturated fatty acid. Similarly, the polyunsaturated fatty acid, which is abbreviated by PUVA, existed in cis configuration, naturally occurring lipid, as I said before few seconds, in hardened fat في الدهون الصلبة. Trans fatty acid may be present. يعني خلي في بالك انه الهاردن fats mainly with trans, while the most liquid fat, oily fat, with the cis configuration. Unsaturated fatty acids are also designated as three family. The first one called omega-3, as we said in the naming of the carbon atom from the methyl group, we call the first carbon atom omega-1, omega-2, omega-3, and etc. Here we have three types of omega family, omega-3 family, and the most common example the linolenic acid, and the omega-6 family اللي هو linoleic and arachidonic acid, and the omega-9 family, which is the represented by oleic acid. The question here, issue here, why we call this omega-3, why we call this omega-6 and omega-9. This is because انتبهوا بقى برجع easy ليش easy because the double bond located situated between the carbon number 3 and carbon number 4 in the omega-3 family, while the double bond in omega-6 family located between carbon number 6 and 7, and the same thing for omega-9 family, the double bond is located between the carbon number 9 and carbon number 10. Is that clear? inshallah واضح. I will jump to the most important thing, the general properties of fatty acid. طلاب شوي انت focus with me please, pay a little attention with me for the general properties of fatty acid. The first property is called hydrogenation, and this is restricted to unsaturated fatty acid only. الهيدروجينيشن property restricted or confirmed تقتصر على unsaturated fatty acid. So the unsaturated fatty acid in presence of water may be converted to the corresponding saturated fatty acid by hydrogenation. What I mean by hydrogenation? That's mean dehydrogenation due to the presence of water. I'm going to fracture to break down the double bond in this unsaturated fatty acid and converted the unsaturated fatty acid to saturated one. And I give you this example. Linolenic acid with the three double bond. If we break down the first one, it's converted to linoleic acid. Same number carbon atom, but here with linolenic with the three double bond, while linoleic acid with two double bond. If I am going to break down the second double bond in linoleic acid, and this will convert it to what is called oleic acid, which is another unsaturated fatty acid with single double bond. If I break down the last double bond in oleic acid, this oleic acid will convert it to stearic acid, which is saturated fatty acid without double bond. This is called hydrogenation. Regarding halogenation, حقيقة ما أريد أطول عليكم, أنا just concentrate with me. Halogenation, if we, this is also related or associated with unsaturated fatty acid, because unsaturated fatty acid, when I said unsaturated fatty acid, I said there is a double bond. When treated this unsaturated fatty acid with halogen, أقصد بالهالوجين for example هو الأيودايد or iodine, under specific conditions, so this unsaturated fatty acid can take two halogen per double bond. يعني كل double bond تقدر تاخذ two halogen, two iodine. So for this specific property of unsaturated fatty acid to taken up two halogen, this is we can know If I give you an unknown unsaturated fatty acid and ask you how many double bond this unsaturated fatty acid contain, I can know the number of double bond by putting this unsaturated fatty acid with halogens. If two double bonds will take in four, because each double bond will take two halogen. If three will take in six. So this is kind of regarded an index of the degree of unsaturation. This is important. Regarding the melting point, sorry, regarding the melting points, the short in general, the short and medium chain, of course, saturated fatty acids are liquid, whereas long chain fatty acids are solid at 25 centigrade room temperature. So the high melting point is due to the close packing of the straight chain fatty acid molecules, as I said before. This is regarding the saturated fatty acid. The saturated fatty acid has a higher melting and boiling point in comparison with unsaturated fatty acid, because the unsaturated fatty acid have a lower melting point and boiling point due to loose packing of the cis configuration due to presence of the double bond. Both the fourth property of fatty acid was salt formation. What I mean by salt formation? If I bring whether saturated or unsaturated fatty acid and bring a salt represented by, I mean, sodium hydroxide or potassium hydroxide, and mixing them, this will form a sodium and potassium salt اللي هو الصوب صابون اللي نغسل washing بإيدينا. Okay, this is called salt formation, which is both saturated and unsaturated fatty acid can form salt in the presence of sodium hydroxide and potassium hydroxide. The fifth property, which is called ester formation, also both type of fatty acid form ester with alcohol. As I said in lecture yesterday, the major alcohol connected or binding to the fatty acid called glycerol, or higher molecular weight monohydric alcohol in lipid-like waxes. So fatty acid can form mono, dia, and tri esters with alcohol groups of glycerol. If three carbon atoms of glycerol connected with fatty acid, this is all called a triacyl glycerol or triglycerides, which is known as a neutral fat, which is the commonest type in our dietary lipid or fat. The sixth property, the oxidation of the fatty acid. As I said, our body need energy, and this energy can get it from glucose, the first line of energy in our body in form of glycolysis process. This will yield an energy. Pyruvic acid by pyruvic dehydrogenase enzyme will convert it to acetyl coenzyme A, and this will enter the citric acid cycle, and each single molecule of acetyl coenzyme A entering the citric acid cycle will give us or yield 12 ATP. Okay, so if there is no glucose, if our body consume all the glucose in our blood and all the glycogen storage in the liver, there is an alternative mechanism to get energy from the adipose tissue by doing a beta oxidation. All fatty acid undergo oxidation in the body to give energy, and the beta oxidation is the major process, because we have another process of oxidation called alpha oxidation and other. In the mitochondria, this free fatty acid, and I'm going to talk about the beta oxidation in the lectures. When the fatty acid enter the mitochondria, this will give us a reducing equivalent in form of FADH2 or NADH, and this in turn will enter respiratory chain to give us ATPs, and the resultant of the beta oxidation is the acetyl coenzyme A and propionic acid, and both of them will enter the citric acid cycle and give us more and more of the amount of the ATP required by our body for exercise during the daily movement. Even this eyelid movement need energy. And the last property here in this lecture is the reduction of the fatty acid. You have to know the fatty acid can be reduced to fatty aldehydes and fatty alcohols and more other type of reduction. Here I just mentioned two type of reduction. What about the fate of fatty acid? Please طلابنا الأعزاء، إذا صار كاتابوليزم ليبيد كاتابوليزم lipolysis triglyceride catabolized breaking down to glycerol and fatty acid. free fatty acid وين يروح بابا؟ شنو مصير الفاتي اسيد؟ الفري فاتي اسيد اللي هو اللي يسمونه ان استرفايد fatty acid. As we said, it's lipid doesn't soluble in water, so this will bind to albumin in the plasma and transported to our body tissues for oxidation, or can be involved in the synthesis or synthesis of the triglyceride as in the liver, or involved in body cell membrane. يعني الفري fatty acid after catabolism either يفيدنا in our body for oxidation to yield energy, or involved in the synthesis of triglyceride in the liver. من أقول in the liver this شو اللي بالليفر شو يسوي الترايجليسرايد؟ to be incorporated in the low density lipoprotein. من نجي نحكي عن اللايبوبروتين راح تعرفون انه اللايبوبروتين او low density lipoprotein, very low density lipoprotein filled rich with triglyceride just like chylomicron. منين يجي الترايجليسرايد؟ in the chylomicron الترايجليسرايد mainly come from the dietary source, while here in the liver the triglyceride synthesized by the liver to be incorporated in the very low density lipoprotein, or as we see it, or involve the free fatty acid in the body cell membrane, because the bilayer cell membrane mainly made from the lipid in form of phospholipid and cholesterol ester, and both of them contain fatty acid. The most important thing here, the beta oxidation process. اوكي صار lipolysis طلع لنا الفري fatty acid. As you know, the free fatty acid will be available in the cytoplasm of the cell. Okay? And the beta oxidation, the site of occurrence of beta oxidation inside the mitochondria. So we have to move the fatty acid from the cytoplasm to enter the mitochondrial matrix. Okay, by which mechanism we can doing this? How can the fatty acid enter the mitochondria? So we have to activate this fatty acid in the cytoplasm before the entry of the fatty acid, the activated fatty acid, to the mitochondrial matrix. And this can be done or accomplished by enzyme called fatty acid synthetase enzyme, which is catabolize or catalyze two-step reaction, as you see in this figure. Two-step reaction. The first one by a thiokinase enzyme or kinase enzyme, the fatty acid in the presence of ATP, adenosine triphosphate, will convert the fatty acid to acyl adenylate اللي هو connected with adenosine monophosphate plus شنو inorganic pyrophosphate. The second step of this reactions, the acyl adenylate in the presence of CoA, coenzyme, and by the presence or by the action of synthase enzyme will convert the acyl adenylate to acyl coenzyme A, which is called the activated fatty acid, called acyl coenzyme A plus adenine monophosphate. This is the first step of beta oxidation. Please, you have to remember in this two-step reaction consume two ATPs, يستهلك 2 ATP, because the beta oxidation is an energy yielding process, not energy consuming process. So remember always the first step of the beta oxidation, we have to activate the fatty acid by the action of the synthetase enzyme, and these two-step reactions catalyzed by this enzyme consume 2 ATP. So لحد هنا احنا خلينا الفاتي acid activated. So what next? By which mechanism this activated fatty acid can enter the mitochondria? هم حكاية هم سالفة. So regarding the transportation into mitochondrial matrix, there is what is called carnitine shuttle. Carnitine shuttle. شنو هاي الكارنيتين شتل باب؟ Carnitine shuttles composed of three important enzymes. The first enzyme called carnitine acyltransferase 1, which is located in the outer mitochondrial membrane, and the second one called the translocase enzyme, which is located in the intermembrane space, and the third one called carnitine acyltransferase 2, which is located in the inner in the inner mitochondrial membrane. First of all, as you see here in the red or pink color, the activated fatty acid اللي هو acyl coenzyme A binding to the carnitine by the action of the carnitine acyltransferase will form acyl carnitine, and by translocase enzyme راح يخليه يدخل خلال الانترمembrane space to the inner mitochondrial membrane, and by the action of the carnitine acyltransferase 2 and will remove the acyl coenzyme A from the acyl carnitine, as you see. Please concentrate with me, focus with me. And the carnitine reused again, and the cycle repeated itself more and more. Is that clear? I believe is that clear. إن شاء الله واضحة ما بيها شيء. The activated fatty acid will bind with carnitine by the action of the carnitine acyltransferase 1 يدخل من السيتوبلازم to the intermembrane space. بعدين ينطي للترانسلوكيز enzyme. This will bring the activated fatty acid in form of acylcarnitine to the inner mitochondrial membrane. In the inner mitochondrial membrane, there is another enzyme called carnitine acyltransferase 2, and this will catalyze the removing of acyl coenzyme A from the acylcarnitine and free the carnitine to be used again, and repeat the cycle more and more. Now, the activated fatty acid available in the mitochondrial matrix. لحد الآن إحنا ما مسوينش، فقط حفزنا نشطنا activation سوينا على بالسيتوبلازم، عبرنا الجدار اللي هو by the carnitine shuttle. Now the activated fatty acid is available inside the mitochondrial matrix. The beta oxidation here inside the mitochondrial matrix. Of course, you have to know as easy as that. The beta oxidation include or involve 4 important steps. Sorry. First of all, as you see here, of course, the equation and the structures for observation, what you have to know the name of the activated or the fatty acid, the name of the reducing equivalent here in form of FAD and FAD H2, the name of the enzymes catalyze the phase steps, and so, and this for each step. For step, you have to know what I said. Now, so the activated fatty acid available inside the mitochondrial matrix or by the presence of reducing equivalent fat, this will catalyzed by what is called the acyl coenzyme A dehydrogenase enzyme. When we said oxidation, we mean dehydrogenase enzyme. When we said reduction and reducing, what do I mean by this? Reductase enzyme. Okay? So the acyl coenzyme A dehydrogenase will convert the acyl coenzyme A to what is called trans delta 2 enol coenzyme A. What I mean by that? So هذا الإنزيم by presence of FAD, and this will liberate one molecule of FAD H2, which is a reducing equivalent, which is a source of energy. Convert the acyl coenzyme A to trans delta 2 enol coenzyme A. As you see, this enzyme will create a double bond between the carbon number 2 and the carbon number 3. So this is called the trans delta 2 enol coenzyme A. Okay, is that clear? Okay. The second most important step, the formation of beta or alpha-3 hydroxyacyl coenzyme A. This, the first step, we create a double bond. The second step, we're going to break down the double bond again. Okay? In the second step, the trans delta to enol coenzyme A, by the presence of water, by the action of enzyme called hydratase enzyme, this will break down or fracture the double bond and going to insert a hydroxyl group on the third carbon atoms, so-called beta hydroxy or alpha-3 hydroxyacyl coenzyme A. As easy as that. This is regarding the step 2. Regarding the step 3, after formation of beta hydroxy or alpha-3 hydroxyacyl coenzyme A, this is another step of oxidation. The first step and third step of beta oxidation include oxidation of fatty acid. The first step and the third step of beta oxidation, including the oxidation, that means there is a dehydrogenase enzyme should be available. So the beta hydroxyacyl coenzyme A is converted by the action of hydroxy or 3-hydroxyacyl coenzyme A dehydrogenase in the presence of reducing equivalent NAD, not FAD. Here, as you look, NAD is converted to NADH, not to NADH2. The issue here, question here, this is requested. If God will, I will make a quiz in the next week about these two lectures. And one of the question, why then FAD converted to FAD H2 and NAD is converted to NAD H1 and NAD H, not NAD H2. Please keep it in your mind. And you have to search about a right answer and solution. So by the action of alpha-3-hydroxyacyl coenzyme A, presence of NAD, reducing equivalent, the dehydrogenase enzyme will convert this hydroxyacyl coenzyme A to what's called the 3-keto-acyl coenzyme A. Again, why keto, 3-keto? In the second step, insert hydroxyl group. In the third step of beta oxidation, as you see in the red, the double bond here between carbon and oxygen, this is called keto group. So 3 keto acyl coenzyme A. The fourth step of beta oxidation called theolytic cleavage or step. What I mean by it? Of course you have to know طلاب شوي وياي. Beta oxidation يا اما يدخلها الفاتي اسيد as we said يا اما in even number or odd number. اوكي؟ اذا دخل even number يعني زوجي دخل 16 بالتالي يطلع لنا last step after طبعا هي كل step oxygen every step طبعا each of 4 step regarding a one round, one cycle, and the cycle repeat itself till these 16, for example, 16 carbon atoms, each turn equals 2 carbon. Okay. بابا.
دكتور طبعا دكتور
أعيد؟
دكتور
أنا سمعت بابا احكي. سمعت
دكتور ما أعرف إذا تسمعني أو لا. أنا أعتذر عن القطعة، ولكن دكتور المية ساعة ويطلع، يمكن هاي خامس مرة يطلع ويقول لك كانت جودة المقارنة. يعني فيا ريت إذا تسمعني، يعني هسه ما أسمع.
أنا سمع شوكي كملي. بابا كملي. ما سمعت. هو النت تعبان يعني ايش بيدي انا عليكم، انا اسف جدا بس هاي فد شيء لازم نسوي محاضرة ان شاء الله
دكتور.
وانا بكل عيني.
دكتور تقدر مثلا وقت المحاضرة دكتور وقت المحاضرة مثلا تخليها من وقت يعني نت الساعة 11:30 وقت كلش تعبان ما يساعد.
مو انتوا عندكم محاضرة يا دكتور غيري قبلها؟ انا ملتزم بالجدول مو بكيفي بابا، انا ما عندي مشكلة.
مثلا قبل 8:30 يعني تقدر؟
8:30 الصبح؟
قبلها
قبل 8:30 الصبح؟ لو قبل 8:30 بالليل؟
اي اذا تقدر لا بالليل هم ضعيف والله نت، يعني هو بس الصبحية قوي يعني عداها لا والله ضعيف.
مو بابا هاي انت ممثل مرحله وانا لازم ممثل مرحله احكي. الممثل مرحله المفروض هاي يتفق ويا رئيس الفرع ويتخبر مثلا هاي تبليغ مو بكيفي بابا، انا لو عليه ما عندي اي مشكله اعطيكم اياها.
ماشي دكتور لا راحته.
اوكي انا ما عندي اي مشكله اعطيكم اياها، وراح ادز لكم هسه ان شاء الله، هم ادز لكم اياها وورد على مود تشوفوها، وراح ان شاء الله هم اعطوني مجال اسجل لكم اياها على اليوتيوب، ادز لكم الاثنين مال البارحه ومالت اليوم. يعني كلش ما واضح الصوت؟
تمام دكتور مشكور.
كلش ما واضح الصوت؟
اي والله دكتور اي والله دكتور يقطع كل شيء ما افتهمنا.
ايش بيدي عليكم على هالنت هذا، احنا بالعراق هاي مشكلتنا هاي. الله يسهل ان شاء الله. الله يسهل. حياكم الله.
الله يسهل. مشكورين.
حياك الله حبيبي. The fourth step of the beta oxidation is called theolytic cleavage. وصلنا يعني شنو theolytic؟ يعني اكفد انزيم يقص لنا 2 carbon atoms from the original fatty acid. بدينا ب 16 قص له 2 in form of acetyl coenzyme A بقى 14 وتعيد السايكل نفسها ل 14 نقص 2 اسيتايل كوانزيم اي باي ثايوليز انزيم يبقى 12 وهلم 12 يبقى 10 الى ان يبقى بالاخير 4 كربون اتومز اللي تنطينا 2 اسيتايل كوانزيم اي. This is regarding the even number fatty acid. اذا زوجي اذا even number fatty acid الاكسيديشن حلوه وسهله، مجرد بالاخير تنطينا 2 اسيتايل كوانزيم اي، ماكو شيء زايد يطلع. اوكي يخلص الفاتي اسيد، و each fatty acid each acetyl coenzyme A will enter the citric acid cycle for further oxidation. زين اذا قلت لكم انه يابا odd number فاتي اسيد 17 او 19 بالنهايه ايش راح ينطيني؟ عذرا اسمحوا لي طلاب. الو سيد، انا اسف جدا انا عندي محاضره هسه بنص المحاضره. لا تنتظرون، انا باكر محاضرتكم باكر ان شاء الله. ماشي يلا حياك الله. هلا سيد. اوكي سوري طلاب. اذا كان اود نمبر، طبعا اذا كان اود نمبر بالاخير راح يصفن 5 مو 4. ومن خلال the action of thiolase enzyme or thiolase enzyme will exercise to in form of a style ويبقى لنا 3. هاي الثلاثة يسمونها propanoic acid وإلها our body نخلي لها حل. There is a solution to convert this propanyl coenzyme A to what is called succinyl coenzyme A على مود ندخله بالستريك acid cycle وينتج لنا further oxidation. لذلك you have to keep in your mind بابا، خلوا ببالك إذا even number شغلة محلولة at the end of the each round each turn of the beta oxidation ينطيني شنو؟ ينطيني acetyl coenzyme A وذا final step راح ينطيني 2 acetyl coenzyme A. خلاص إذا كان odd number لا، the final step of beta oxidation will excise the 5 carbon atom compound to 2 acetyl 2 carbon atom in form of acetyl coenzyme A or what is called propanyl or propanic acid or propanyl coenzyme A اللي هو 3 carbon atoms. or both of them can enter the citric acid cycle. الأسيتايل coenzyme A يدخل الcitric acid cycle directly, but the propanyl coenzyme A have to be changed to the succinyl coenzyme A through conversion through 3 steps وراح نحكيها إن شاء الله تباعا على مود يدخل لنا وين للcitric acid cycle to yield a further oxidation needed by our body اللي نحتاجها. This table هذا التيبل as you see بكل الانزيمز بكل التفاعلات اللي تحتاج. كل الليكتشر included in this table. Please you have to read this table carefully. حقيقة طلاب regarding the energy yielded by beta oxidation اكو طبعا question always احنا نسأله ولازم تعرفوا باب. اذا اسألك if I ask you what are the energy or the amount of energy yielded by the beta oxidation of 16 carbon atoms in bracket بين قوسين palmitic acid، تقول لي شو تقول لي؟ شلون تحسب لي؟ هسه راح I'm going to tell you how you can calculate and measure the amount of ATP yielded by beta oxidation only and the total ATPs or energy yielded by the oxidation of fatty acid by the beta oxidation and citric acid cycle. There is a difference. إذا قلت لك beta oxidation only تحسب لي اياها عدل، تحسب لي بس الناد والفات. إذا أقول لك احسب لي total oxidation by beta oxidation and citric acid cycle لا، تحسب لي الناد والفات and plus the number of acetyl coenzyme A اللي راح يدخل الcitric acid cycle. ومثل ما قلت لك إنه كل acetyl every one single molecule of acetyl coenzyme A entering the citric acid cycle will give us 12 ATPs، تنطينا 12 ATP. هسه نجي شلون نحسب؟ مثل ما تشوفون طلاب as you see in this page we will take the palmitic acid. من أقول palmitic acid يعني 16 carbon atoms. Okay, as an example. So to complete the oxidation of 16 carbon atom دا أحكي لكم على الستريك قبل الستريك acid cycle. palmitic acid ايش قد؟ 16. Okay. كم راوند على مود ينطينا at finally 2 acetyl coenzyme A؟ ايش قد؟ هسه علمك شلون تحسب. طبعا of course you have to keep in your mind the number of the fatty acid I give you. هنا قايل لك palmitic acid اللي هو 16 carbon atoms as easy as that divided by 2 قسمه على 2 16 تقسيم 2 ينطينا 8. هاي ال 8 ايش تعني لي؟ تعني لي number of acetyl coenzyme A not the number of NAD or FAD H2. اوكي؟ اقسم 16 على 2 ينطيني 8. شنو معنى الثمانية؟ 8 meaning the number of acetyl coenzyme A. سجلها يمك number of acetyl A 8. اوكي. بعد ايش قد النمبر اوف الفاد H2 والنات H؟ نفس هاي الثمانية النمبر طلعناها number of 8 ناقص 1 8 minus 1 will give us equal 7. What I mean by 7? This is the number of FAD-H2 and NADH. Okay? Number of FAD-H2 and NADH. إذا أقول لك calculate the energy yield by the beta oxidation only، طبعا هنا for this example شو تقول لي؟ will multiply 7 by 2 regarding FAD-H2. لازم تعرفون ان الفاد H2 ينطيني 2 ATP والناد H ينطيني 3 ATP. فمن تجي تضرب عددها طلعنا ايش قد؟ 7. 7 multiply by 2 equal 14 ATP. Regarding NAD H, 7 multiplied by 3 equal 21. So the total summation of 14 plus 21, this will ايش قد يساوي لنا؟ 35 ATP. So the total energy by only beta oxidation of palmitic acid ايش قد يساوي؟ تقول لي 35 ATP. سوري اقول لك لا بابا، لازم تتذكر انه عندنا step of activation in the cytoplasm consume 2 ATP. تقول 35 minus 2 ينطينا ايش قد؟ 33 ATPs. The total energy yielded by complete oxidation of palmitic acid by beta oxidation only. عشان إذا أقول لك total oxidation هسه نرجع للثمانية، قسمنا أول شيء مو قلنا 16 divided by 2 equal 8. 8 acetyl coenzyme A. Each acetyl coenzyme A when enter the citric acid cycle will give us how many ATP? 12 ATP. So we'll multiply the 8 by 12. This will give us 96 ATP. 96 plus 35, this is will equal 131 ATPs. At total number of beta oxidation and citric acid cycle minus 2, and this will give us 129 ATP, and this is the correct answer about the amount or the number of the ATP yielding by complete oxidation of 16 carbon atoms, I mean palmitic acid, by beta oxidation and citric acid cycle. Okay? إن شاء الله واضحة وسهلة جدا، سهلة، شغلة رياضيات لا بها طب ولا بها أي شيء. اللي يهمني أني as you إن شاء الله as a project of a future doctor، مثل ما أنتم إن شاء الله مشاريع أطباء المستقبل، لازم أحكي لكم عن clinical disorder associated with beta oxidation of fatty acid. Clinical disorder associated with beta oxidation of fatty acid. Always remember إنه short chain fatty acid يدخل الميتوكوندريا without carnitine shuttle. Short chain، ذكروا بابا، short chain fatty acid يدخل pass freely through the mitochondrial membrane to the mitochondrial matrix. Okay, while the medium chain and the long chain fatty acid need the carnitine shuttle to enter the mitochondrial matrix. Okay, خلصنا. So if there is a medium chain acyl coenzyme A dehydrogenase enzyme deficiency inside الميتوكوندريا، ما نحكي عن الكارنتين شتل، على البيتا اوكسيديشن، مو قلنا عندنا تو ستيب اللي هو 1 and step number 3 اللي هم يصير بين اوكسيديشن. من اقول اوكسيديشن يعني اكو 2 dehydrogenase enzyme. If we have a deficiency or a defect in medium chain acyl coenzyme A dehydrogenase enzyme، إذا ماكو dehydrogenase beta oxidation of course automatically will be stopped. So there is no yielding acetyl coenzyme A, and this will lead to accumulation of شنو؟ accumulation of fatty acid. إذا fatty acid صار accumulation وما راح صار oxidation beta oxidation، يعني ماكو energy productions. Our body depend on what? Depend totally entirely to consume the glucose depend on carbohydrate. راح يخلص لنا الجلوكوز اللي راح يسوي لنا severe hypoglycemia. إذا صار انخفاض سكر شديد حتى يسوي لنا death، يؤدي إلى sudden infant death syndrome، يؤدي in 10% of cases يعني إلى موت شنو؟ طفل الانفانت sudden infant death syndrome. ليش؟ لأن due to severe hypoglycemia, shock and death. لأن our body cannot use شنو؟ الفاتي